Oh, we're done.
We're done? No, I'm done. All right, so you'll flip the pages for me?
Yep.
All right. Oh, hey, look at that. So who here has a 3D printer? Who here are thinking about 3D printers? Yeah. All right, very good. So this particular 3D printer is what they call FDM. It's a fusion deposition modeling. So what it does, it actually imparts a medium, this one, and builds up layers, one layer after another. So tonight we're going to talk about what a 3D printer is, what it does, a little bit of the history, the types of 3D printers, because there are several different types. I think, Keith, you had a very interesting one, a Delta. You had a Delta. How do you like the Delta printer?
Pretty good.
Yeah. Yeah.
You just sit there and stare at it.
Yeah, not like this one, you can't.
No,
The Delta printer, it's tall, it's got 3 points, and it's got 3 lines that come down and a head right in the middle, and this thing just spins around. It's quite interesting. So we're going to talk about the 3 different type of printers, the main ones that we would be using. The type of technologies, the pros and cons, applications for hands, which is all what we're all interested in, right? Because, you know, there's only so many benchies you can print. Who here knows what a benchy is? It's a little tiny tugboat that comes with every single 3D printer for you to print. Yeah. The interesting thing about the benchy is while it doesn't look like much, it actually tests a lot of different things on the printer. So that's one of the reasons why everybody prints one. I have several. All right, and then we're going to talk a little bit about the future of 3D printing and then the software that you're going to need to run this. The slicing software, and if you are so designing software. Can't find it on the internet, make it yourself. Don't be at the mercy of the dealers. All right, so 3D printing is additive manufacturing, right? There you go. So when I first did this, about 4 years, it's about 6 years ago, I got my first 3D printer, about 6 years ago. And I go to Audrey and said, hey, I'm going to get a 3D printer. And the first word out of her mouth was, what? And I said, oh, because you can do this, you can do that, and blah, blah, blah. Well, she has now become a convert. She asks me all sorts of stuff for her. So it's additive manufacturing, and it prints 3-dimensional objects. I've got a bunch of them up here. You guys can come up on the break and take a look if you haven't already. And the printer right now is working. So how does it work? So you create a digital model, or you can download one off the internet. There is absolutely no shortage of stuff you can download, for sure. The model is then sliced into layers. So think of a loaf of bread standing up vertically. And it just builds one slice on top of another, on top of another. And that's what the models are sliced through the 3D printers. You send it to the printer, and there are several different slicing programs that will talk to the printer, or build the file, and then you can save it on your board. And then the printer builds everything layer by layer. It's just one thing on top of another. Go ahead. Next. Yes, the very first 3D printer. Granted, it was limited in what shapes you could do with it, but that's basically what your 3D printer is doing. Imagine taking this, rotating it, roughly 90 degrees, so this hangs down, and it just extrudes it out. So in the 1980s, there was the patent for sterile lithography, which is what 3D printing is. And in the 1990s, SLS, which is a sintering method, and FDM, which is the melting plastic or whatever else you want, in very thin lines, and building it up came to be. In 2000 was a renaissance for 3D printers. It really hit the mainstream. The prices started coming down. Initially, 3D printers were really only for people who do prototyping and everything else, and printers that sat on desks like this were $10,000 and $20,000. They were very expensive. They were slow, very slow. So all the open source projects. So what happens now is we have all these controller boards and a myriad of software, firmware, that you can run on it. You don't like how this particular firmware is running, you can run it on another one. So the 2010 and beyond, it's in many different industries now, 3D printing. You know, you can 3D print cake, icing, medical, they're 3D printing skin, they're 3D printing organs, they're 3D printing bone. They're doing a lot of things. So 3D printers have come a long way in what they do. So, and they're certainly much more accessible now. Go ahead, next one. So there are several different types of printers. Each has their own pro and con. This is the very first one that I had. It was made by Ender. It's called the Ender 3. It's probably the most famous 3D printer.
Yeah.
Because it was $200. Yep. That you could buy it for over here. Was it a good printer? Yeah. Well, you could get it to work. And we'll go into that a little bit later as to what you get when you start spending a little bit more money. So that's that one. This one here is basically this type of printer here. This is called a Core XY. So this one here, the bed moves up and down. Not back and forth, just up and down. It's called a Core XY. This one here is called the bed slinger, because the bed actually does your wide motion, right? It's back and forth. And then the head itself does the X and it does the Z. So it raises it up. This one here, called Core XY, the bed does the Z. It moves down as you print. Delta printer. There you go. Great printer, fast for its time. Much faster than this. When I first got my printer and I plugged it in, figured out how to level the bed and get it set up just right, that little tiny tugboat, that little tiny bedsheet, took an hour, 20 minutes, somewhere around that time frame to print. This printer prints the same bedsheet, same size, same amount of material, about 15 minutes. So it can be quite a bit faster, which is nice if you're, let's say you're doing some prototyping, you want to try something out, you don't know if it's going to work, and you want something real quick. That you can do. Other than that, this one, you're going to wait a while. And this is the newest type of 3D printer. It's a robotic arm. How many of you have seen the YouTube videos where they're 3D printing a house? Oh. Right? That's kind of what they're doing there. They're using a robotic arm. The thing just spins around and prints the walls, and leaves the holes for the windows and the doors. So it's kind of interesting. All right, so the Core XY is more advanced. That's this one here. A system that keeps the bed stationary. It just drops it. The biggest, it reduces motion jitter. We've all heard of with jitter. Think of jitter as when you turn your digital audio processing on your HF radio and it's up a little bit too high. Everybody sounds kind of garble. Well, take that garbling, convert it into vibrations, and that goes right down into your print. You'll see those little waves and lines in your print. 4XY printers are much better at not having those ringing artifacts. So this particular printer is belt-driven. It allows for pretty fast printing and better accuracy. You need a lot of accuracy if you're going to put one line on top of another and want to build something that's straight, flat, right? So, okay. And typically these printers take up a lot less space. They're enclosed, and the bed goes up and down. You don't have a bed like, you don't have a bed that's actually moving anywhere from 3 to 4 inches, maybe even 5 inches, back and forth, so you need a lot of room front and behind. All right, so the cons for that printer, besides the cost of getting into it, the initial cost, they're more complex to build, and that makes them a bit more expensive. A bit more, well, one, it's expensive, but two, you can get a lot more features. The biggest thing on this one that I've had to do is belt tension. There's belts everywhere. There's belts that run the X and the X and the Y up here. There's belts that run the Z axis for the table, and they all have to be tensioned every so often. All right, so the Delta printer is very fast and very lightweight. So the Delta printers print much faster than this one can do. This one here will do what they call ludicrous speed, is 600 millimeters a second. That's pretty quick. You need to use different filament for that. You can't just use the regular PLA filament that you're using in your bed slinger or when you print slower on you. Because what happens is you're coming through a little tiny nozzle, 0.4 millimeters. And you're taking something that's 1.75 millimeters, which is the diameter of the filament, you're heating it up and you're squishing it, forcing it through that little tiny hole. How fast you can go is a comment of how viscous the plastic is. Well, if you get it too hot, it just melts and go all over the place. If you get it too cold, cooler, it's not going to melt correctly, and it's going to clog your nozzle because you're trying to print too fast. So there's a fine balancing. Luckily, today's printers kind of handle mechanics of all that. Let's see here. So the Delta printer is great for tall cylindrical objects. Make a hand base, right? So, and they're good for other things as well. But Anycubic Cobra and FL Sun Super Racer are two of the very good models that are out there. The Delta printers can struggle a little bit with flat, square sides. They really have got to be dialed in on those outer edges, so you can have a little bit of trouble with it. The Scara, we're not going to really go too much into. That's the rotating arm. These two here are quite different. They're very interesting. This one here is a resin printer. So instead of using plastic, you're using a resin. Then you pour the resin in, the plate comes down and just touches the resin, goes down just below the surface, and there's UV light. It's a pinpoint of a UV light. And it hits the resin. When it hits the resin, it solidifies it. And again, you're still doing the same thing, layer by layer by layer by layer, but you're doing it in resin. The drawback to that is there is a lot more cleanup afterwards. You just can't pull the part off, go, oh, it looks nice, I'm gonna go use it. You gotta get on your gloves. You don't want that stuff on your fingers. And you gotta wash it. And you usually wash it in isopropyl alcohol in a vibrating dental bit. Just let it run. And then when you take it out, then from there you can take off the supports if it has any. And then you have to put it into a UV chamber to harden it. Now the benefit to this is much finer detail in layer levels. That would be more useful for someone who's into Dungeons and Dragons and making models. Right? That's what this one's for. This one here is called sintering, and it uses a powder. If you want to see it in operation next time you're down in Santa Monica, there is a place down in Santa Monica that will scan you, your whole body, or whoever you have with you. You stand there, does a 360-degree scan of you. And then they use this sintering method, and they build it up again, still layer by layer by layer. And once they pull it out, they have to, again, there's a lot of post-processing that goes along with that. But quite interesting. And DLP is digital light processing. We all had heard of DLP televisions and stuff. Same basic principle. The DLP is a little bit higher version than the regular SLS, the printer that uses the resin. Both use resin, but the DLP is much finer resolution. Okay. So the FDM printers are the most popular. One of the reasons they're the most popular is, one, they just work. Two, you can get them in a whole range of prices. You can go from $300 all the way up to, I think Prusa has one now that does 4 colors, but what they do it a little bit differently. It has 4 different heads. So it'll actually, when it's done with the one color, it'll stop, go up, change its head, and then come back down. And what that does is it prevents the printer from pooping. This one, every time you change color, we have printer poop. And if you have multiple layers with multiple colors, it's going to do that several times. And it really extends the time of the print. Because every time it does that, it's got to go up, it's got to purge the old filament, it's got to pull back the filament, it's got to put a new filament in line, it's got to run it through and make sure that the old stuff is still out of the heat chamber, and then it can start printing. And it also prints what they call a prime tower. Well, that's a separate little piece that's usually done in the back, and every time you print a layer, even if it's the same color, it moves over to the prime tower and prints the same layer. And does that back and forth until the color changes. Then it changes the color, runs it on the prime tower, and goes out, does it again, and just goes back and forth. So these little challenge coins that I made they were done on this printer. And there's 3 colors. So you can imagine the fun I had figuring out how to get that going. It was a lot of fun. All right, so SLA printers, they print by curing resin. Touched on that a little bit. DLP does the same thing, just a little bit higher. Sintering uses powder. So they all work basically the same. They all print layer by layer. Doesn't matter whether it's this type, whether it's resin, whether it's the SLS. Yes?
Great question regarding it sounds like you're plastic and resin, but when you talked about like the organ tissues, what material is it?
Those are those are specialized printers. That probably cost hundreds of thousands of dollars.
Different.
And not to mention what the material costs are for that. I have no idea.
I see.
Yeah.
So it's not only, they can manufacture You said something about houses too, so.
Right, so different printers, so this one, the big one that they use, is kind of, it's not a Core XY, but it's a big robotic arm, and it just runs out and, you know, pukes out cement and
I see.
runs it through a line.
So it could be any material. Well,
All right, let's move on to the next one. All right, so experience level. Very similar to ham radio. When we started off, and all started off in this hobby, what did we know about ham radio? Nothing. We knew jack, right? We didn't know much, and it's a learning hobby. So is this. So your experience level goes. The learning curve is really steep, especially when you first start. Same thing with ham radio. What you need to look for is your intended applications. What do you think your majority of the time you want to make with it? So you want to make enclosures, you want to make bits and pieces of parts. You got to look at what you want. How much do you want to spend? Now, here's the fun part about this. Your budget. The next two actually kind of run together, because the more you spend, the higher quality printer you're going to get. Because let's face it, most of all these come from China, almost all. The more you spend, the more you're going to, the better quality you're getting, the faster you're going to get. Some will be more reliable. When I first got my Ender 3, and it's a little bed slinger, it was $200. Did it have bed leveling? No, it did not. Did it have a warped bed? Yes, it did. So this aluminum plate, while I could get the four corners level, the center had a little dip in it. Now, when you're printing with this, between the bed and the tip of that nozzle, that is a very important measurement. If it's too deep, you're going to scratch the bed, and the filament will blow out on either side, or get pushed back into it instead. That's a biggie. So leveling the bed was fun. So what you would do is take a piece of paper, move the head over to one side, lower it down as best you could, and then you had big screws on the bottom of the bed, and you turn them just until that paper would grab the nozzle. You'd have to do that to all four corners. The fun part is, when you got done doing the other three, you go back and check the first one you did, and you find out it's off.
Yeah.
So then you have to go round robin again throughout the whole thing. So, when you start spending money, like this one here, this one has automatic bed leveling. This one also has first layer detection, so it will put down its own little line of filament and then go back and look at it to see if it's right. A lot of times what happens too, and someone was asking if you could just set it and forget it. You know, get a 3D printer, get it going, and just walk away. You can't. Not advisable, because a lot of times 3D prints fail. They fail for a variety of reasons. And the biggest one is maybe the printer skipped a step, maybe your filament wasn't dry enough and there was a little bit of water in there. And when it heated up, it popped. And guess what? It messed up a layer. And what happens when you build upon a messed up layer? You get another messed up layer. And the layer after that. And that's what we call spaghetti. The thing just goes out into a mess because it's just throwing plastic everywhere. And it doesn't stop until you stop it. The more you go up in features on a printer, this one here has spaghetti detection. should have meatballs. But it's got the spaghetti potential. It'll stop. It'll send me a message to my phone, believe it or not, to say, hey, we detected a spaghetti failure. Here's a picture of it. What do you want to do? You know, I can go, hey, I like spaghetti. Or you go in and fix it and then start all over again. So that's, yeah. So it's a lot of fun. Speed, again, you know, some of those cheaper printers, they don't run as fast, which is okay. But if you're impatient, or you're in a little bit of production environment, you're trying to run, you know, oh man, I've got 200 and some odd of these little SO239 dust caps to make for field day. It's going to take you a lot longer on a slower printer, but you can do it. So there you go. Reliability, yeah, you get more reliability. Of course, you get better customer service with that too. The nice thing about the Ender 3 or the really inexpensive printers is you learn how they work. You also learn why they don't work. And there you go. So the different type of filaments for different needs. We'll talk about that here. Is that on the next page? So the different type of filaments. The filaments that I'm printing in, all of these up here. This one here is a little bit higher temperature filament. This one's called PETG. And it's just the acronym for, I forget what it was. And there's also PLA. PLA is very easy to print with. It's very forgiving. It prints at a lower temperature, which is nice. The bad part about PLA is you don't want to leave it in your car and toss it. Because it will take on its own shape. So that's one of the things we do have to worry about. So we want to look at the different filament types. Now you can print from everything from the regular PLA to PETG. You can print with carbon fiber. You can print with nylon. You can print with ABS. And you can print flexible filaments. This one here is a gasket I made for one of our jars at home. It just disintegrated over the years. Well, this is a completely flexible filament that came out of so now, be able to print with some of these other specialty prints, like ABS, ASA, nylon, which gives off some nasty gases. So you don't want to leave this thing printing in your bedroom unless you have a filter for it. You need a heated chamber. When you print with, let's say, ABS, I tried printing with ABS on this computer. It's got a hardened steel nozzle, so it can print the higher abrasive filaments, higher temperature filaments. I'll talk about temperature later. And because the bed and the chamber is heated, it won't warm. A lot of times when you print with some of these higher end filaments, you don't have a heated chamber. Corner of the thing just might lift up just a little bit, and you're going to get some warming. So that's why you look at enclosed printers. So you have to look at what you think you're going to want to print, what you want to print. PLA prints about 190 degrees Celsius, which is what, 350 degrees-ish Fahrenheit. Nylon, ABS, ASA, some of that other stuff prints at 300 degrees, which is over 600 degrees Fahrenheit. So much hotter. Now, the fact that it prints at a hotter temperature means you can leave it in the box. It's not going to deform. All right, next one. So the applications, we talked about the medical field. So I don't know if any of you remember, but during the height of COVID, they were asking
people with 3D printers to print out some of the apparatus for the face shields, not the face shield itself, because the road can't be clear, but we can print out the headband for that. So they were printing out headbands for them. So they were rolling out. So a lot of the people printing all sorts of stuff for the medical field. Prototyping. Let's say you have an idea for something and you sketch that. And you think it would work really well. We'll talk about prototyping here in a little bit when we talk about CAD software, which is a whole other lecture of itself. Aerospace and automotive, a lot of stuff today is printed on 3D printers, both aerospace and automotive, whether it be done in ASA, nylon, plastic, or whether it's done in metal. You can print with metal too. Construction industry, we talked about that. And then everyday use. We had an older refrigerator. We pulled out this internal drawer. It had two little arms on the side that popped up for the Christmas tree. Well, one of them broke. It was because you couldn't buy just the piece that broke.
Oh, yeah.
You had to buy the whole thing, and it was $175. Oh, I thought that was my printer for that, right? So I took the part, I modeled it up, printed it out, and now we have a CRISPR drawer that works for probably 30 cents. And 8 hours of my time because I'm not a CAD person at all. So I have radio, right? So that's what we're all waiting for, right? This here is a wire winder from that I did when we did the CVARC antenna build. It's got a place to hold the transformer and the wrapper wire around it. Power poles, everybody's favorite device. You're building a Go kit. If you were to buy this online, if you were to buy that online, you'd probably spend $10, $15 for it. You can print this for about 80 cents.
I was gonna say $200.
How much was the machine?
And I'll tell you something though,
That's the material.
in the few years that I've owned this machine, because we also sell a few things online, the machine has paid for itself. Okay? We'll get into prices in just a little bit. I had some leftover filament, so I printed out a little stand, and this stand is for the Nano VNA, or the SA Ultra. Both. Matt printed this out. This is another wire winder. There we go. And so, how many of you here have a Zygo G90? Okay. How about a 991A? Who has that? You can print rails for those things, for both of those. The FTX10 or any of them, you can find them online. You've seen those rails that mount on the side. They're not for mounting it, but they're for protecting the front plate when you have a backpack. Okay. You can print those out. They'll work just fine. A lot of the things that I did, of course, everybody got Christmas gifts one year for the 3D printer because the 3D printer was good. So, one of the things we did, I don't know if you're going to really be able to see this, but the box is 3D printed, and so is this picture that's on here. This is called a lithophane. Oh, that's going to show. And what a lithophane is, lithophanes aren't new. They were being done 1500, 1700s, China. Where they came out of. And what people would do is they would take a sheet of clay and they'd carve into it. And where the clay was left the thickest, it was dark. And where it's light, it's the lightest. It's one of the not hand-radio related, it's still one of the things you can do with it. Well, you know, you can take a picture of yourself on your radio and put that. That makes it handy. There's a call sign. Zach, where are you? There you are. Zach has one.
I know,
This is a little call sign that, right up here, let's pass that around. So, you can print custom enclosures. You have, an ESP, little board. You've got one of the tiny APRS units that you can buy just the board and the antenna. Or an enclosure for it, just like an enclosure for a valve. This is a dipole center. It would go in the center, dipoles go on either side, and this pops open, and it'll hold your valve inside.
What's that printed from?
What's that?
What's that one made of?
This one is made of PETG. And I also used, which was fun, you can get different build plates that have different designs on them. And I don't know if you can see this glistening at all, but the build plate has a little design on it. And that gets imparted into the obviously you can build stands, you can build knobs. You lose a knob for your radio, you build a knob for it. Tags and printed names. We have a little keychain over there with the name on it. You can put the band, so we've got several antennas. You put a little tag on it, so you know that it's, hey, this is the wire for 20 meters, or this is the wire for 40. Keep it easy rather than color coding, because, oh, wait a minute, is red 40, or is that 20? Gaskets we talked about, I printed gaskets. The power pole panel mounts. They can be round, make them square, they can be single or double. Panels, doesn't matter, whatever you want to do, you can do them. This is a fidget spinner. This one is actually quite interesting because it's got movable gears and it was printed in place. So the printer right here just went back and forth and did its thing. And when it was done, it was taken out and the parts moved because it builds in the gap. Anyone want to see it? So the question is, can the expensive printer do that? Yes. Well, I'm sorry, the inexpensive printer. Yes, the inexpensive printer can do that. It's not necessarily to more expensive ones. Good.
Make the holes or you have to do all those holes later?
Oh, that's the holes are there. Now those holes are sized for metal inserts. So if any of you have had plastic items that screw together, you know that maybe you'll get 3, maybe 4 times of unscrewing it and screwing it back in before it starts getting loose. Because it's plastic, right? You're chewing away the plastic. With the Dowling box that's going around, I didn't have time to do it this time. But I've got metal inserts that you heat up with a soldering iron and you push it into the hole. And now you've got metal threaded inserts in the plastic.
Have you ever used a helicoil to do that?
No, not for 3D printing. I've used helicoils because I stripped a spark plug out.
Well,
I've never used it on that.
for non-structural stuff, I've used them, it's really nice that the fiberglass foam you'll use what's called slots. You'll tap the slots, put it in a helicoil, then the slots are very nice, and have a heatable screw joint.
Yeah. Yeah, no, I don't even know if you just use the heated insert. What's that? You can thread the holes too, right? Yeah, absolutely. Just like this is threaded. This is a threaded part. And this came off the printer as well. All right.
The inserts are like.
About 10 minutes before this is done, so it's. Yeah, no, I'm not done yet, so go ahead.
Is there a system, well, not really with the cat, but can you put something on a platform that have it scanned?
Yes.
Makes it.
We're gonna, yes, I'm gonna touch on that a little bit.
Apple laws involved there,
You know, there are a couple of companies that came out. Creality is one. Creality is a huge 3D printer manufacturer. That's where my very first printer came from, the Ender. And they have this camera that can scan, and then the software converts it into a 3D image, something that you can use on the eventually print out. Although I don't think it works very well. It'll give you the general idea. One of the things that I've done in the past is I've taken a picture of what I want. So let's say I'm looking at this gasket, right? I lay it down on the table, I get my camera directly above it, take a picture. I can import this picture into the CAD program. And then I can scale it to the proper size. And then from there, I can do the CAD work, drawing the lines. So, more sustainable materials, PLA, plant-based. Of course, nylon and ABS already. But as far as non-toxic goes, you know, there's some better materials for it. Mass customization and personalization. Again, that's what we're looking to do, not necessarily mass, but for hands, we're looking to make our lives more enjoyable when we're out in the field or doing something. And you can certainly print up stuff for that. They even have kits where you buy the individual little pieces and then you print out your own Morse code files. So you can print out either a straight key or pattern, little tiny.
Okay.
Still using it.
So it like helps protect it.
Yeah. So yeah, talk about faster and larger scale printing and revolution. This was housing, SpaceX housing. Here's one here. Building a wall. Be interested to see how well it holds up. Well, you're using cement, so it probably holds up. There's your spaghetti. Green spaghetti. That happens a lot, believe it or not. A lot of times, the cause for this is that the very first layer you put down didn't stick well. And as subsequent layers go over it, it pushes it and moves it. Once it moves it out of where it's supposed to be, they're stupid. It doesn't know it's not there anymore. It just goes. And that's why you can't leave them alone, depending upon the thing. This one here, you can sort of leave it alone. It'll detect the spaghetti. It takes a little while, but it does detect it, and then it stops the print. So, slicing software. There's several different software. This one here, Bamboo Lab, they came with their own slicing software, which was based on a slicing software called Orca, which was based on a slicing software by Prusa. So, there you go. There are other software you can use. So in your slicing software, you have to give the printers, you have to give the program the parameters for the printer. It has to know what type of printer it is. It's talking to you. The size of the build area. This one here is a medium-sized area. It's 256 by 256, and 256 high. So it's about 10 inches by 10 inches by 10 inches. Printers that can do more. There are printers that print on a conveyor belt. You want to print out a sword all in one piece that's 3 feet long? You can do it. So, the the bottom line is, if you're in your CAD program, you get what you've done, export it, and you export it to an STL file, and then that file is read by your slicing software. It takes it in, it gives you a representation of it. Now, there's some things you can do in the slicing software. It's not really meant for designing. You can make the part a little bit bigger. You can make it a little bit smaller. You can add supports if it needs supports when it prints. Because it can't print in linear. It just doesn't work. You need supports. From there, you slice it up, and it gets sent to the printer. And it gets sent to the printer in what they call G code. G code tells the printer to turn on, to start heating up the bed, to start heating up the nozzle. It can tell it, hey, I need to do a bed leveling, let's do a bed leveling. Let's test that out. I want to do an extrusion test, let's test that as well. And if everything comes out good, send it to the print, and it sends the first layer. It's done. So it sends the first layer. Now the first layer is not just one line, because you've got X and Y coordinates for it, so it has to know where it's going. So drawing a circle like this is just not one line. It's many lines. When it finishes that, it goes to the next one. It either lowers the bed or raises the head up. Let's say 0.2 millimeters, sometimes even less if you want something finer. If you're doing a prototype and you just want it done quicker, you make it a little bit thicker. So basically the slicer takes what you put in the image, slices it into many thin horizontal layers. So you've got layer height. When you look at some of the things that are going on there, if you look on the side, you can see where the layer lines are. Sometimes they're smaller, sometimes they're larger. You're defining your tool path. You're telling this thing, I want to print something round. I want to print it round, I want an 1/8 of an inch thick. And I want it to be just a 1/4 of an inch wide. So you tell it it tells the printer all those things. And the printer goes and does it. Infill, density, and extrusion rates. How fast can your printer print? Well, some of it's just the laws of physics. How much can you push through a 0.4 millimeter nozzle at that time? How hard can it push it? And it all depends upon the filament. Some of it is high flow filament, where this thing can go at its full 600 millimeters a second and just push the filament out, no problem. Other filament is a little bit more viscous, or less viscous, and it's harder to push it out. So you can't go as fast. It needs to spend more time in the heat chamber. Infill. So this is solid. This is not. This is not exactly hollow, but it's got a lattice network for support. One of the things I can show you here is a broken duck's head. And inside the head, let me pass it out. Inside the head, you can see that there's internal supports in there. And that gives strength to the walls and gives strength to the whole part itself. Obviously, that one didn't have enough. That's why it's a duck without a head. A duck without a head without a body. Support structures. So if you're printing this at an angle on a plate, which some people do, and there's reasons for doing that, structural reasons. But if you're printing it at an angle, it's very difficult for the printer to lay some lines out there in midair. It just can't do it. Nothing to hold it up. So you build a support structure that goes up underneath it. and then when it prints, you peel it off. Very similar to that fidget spinner that's running around here. That was printed in place, and it left just enough gap so that the plastic didn't fuse together. All right, so let's take a look. Here they are, the little BNC dust covers. And,
Is it hot?
Oh, yeah, it's hot.
no, this plastic, this particular one doesn't print as hot.
How do you have to prepare the table so that you can remove it
And you want it all
so that it sticks?
There's several different types. This particular one, this has an engineering plate on one side, which is for high temperature. This is for polycarbonates and nylons and stuff like that. This one here is what they call a cool plate. It only heats up to like 50 degrees centigrade. It still gets warm, but it's generally, when I'm printing with PLA, just clean soap and water to clean the plate. And that's all you need. Sometimes if it's having trouble sticking, so some people like to put hairspray on it. I never liked that because it just makes a mess. So there's stuff that you can buy that you can rub on there. Even Elmer's glue stick. Some people use to smear it on the plate, and that helps it stick. So to get this off, that's all you do.
I was gonna ask you about that. A lot of that plate is that big. Can you make it in many small parts as it fit on there?
Yes. Well, there's two issues with that. In older times, in the earlier times, I should say, before a lot of the smarts in the software was created, if you were to print, let's say, 30 of those, if you fit them on there, one of them messed up. There was no way to tell the printer, just ignore that one and print the other ones. Newer software allows the printer for you to tell the printer, hey, this part is messed up, ignore it, and it'll continue printing the rest. Otherwise, what happens? You're 3/4 of the way through, one of them breaks off. You have to stop, you have to trash everything. Because it's still going to try to print the thing that's not there, and it's going to make even more noise. All right, so temperatures, print speed. Other settings. All right, let's go to the next one. All right, real quick, slicer software. I think we're getting a lot into. So, the slicer software is what takes your model and slices it up. Very simple. So, Ultimaker Cura was probably one of the first ones that was out there. It's free. Most of the slicing software is free. It's supported by almost every printer out there. Prusa Slicer, which is developed by Prusa Space. Fabulous printers. Again, they're expensive, but you can get them either assembled or unassembled. You have your choice. They're more expensive because they have more features and they use better quality components. Simplify 3D is another slicer. Bamboo Studio, which is kind of based on the Cura and Prusa. I'm sorry, Orca and Prusa. Orca Slicer is great, and then Litchi, which is popular for the people who want to do resin print. That's where that one comes in. All right, design software. I have to admit, I am not a designer. And you play with it. This is probably where one of the steepest learning curves is. You got something, you can't find it on the web. So you're going to make it yourself. Start off with a little sketch, and then you start drawing, and you keep drawing, and then you realize that's not working, and you start all over again. So there are a couple online free CAD programs that actually help you quite a bit. Tinkercad is one. FreeCAD is also in there as well. Those two, they don't have all the bells and whistles and features you can do, but they're very easy to use. You can very quickly and easily design a box or a stand or a knot, whatever you need. So that really helps you. Fusion 360, that's the industry standard. Most design houses that use them will pay about $20,000, $30,000 for the license. But you, as an individual person, as a hobbyist, who agrees not to be selling anything with it, can use Fusion 360 for free. And it's got a lot of other things that Fusion 360 does. It's way overkill for what we need to do, but it's just an amazing amount of stuff. Blender's another one, SolidWorks. Onshape is really good. That's cloud-based CAD software. Want to stay out of the cloud? Good luck. Most of all of those, except for the Fusion 360, you can keep up. You can keep off the cloud. With Tinkercad and FreeCAD, you can pay a small fee. It is really small, and you can keep your designs private. You know, they won't be searchable. All right.
Just showing support structure inside.
All right, so choosing a printer depends on what you want to print, how much you want to spend. Again, you can start for $300. Now, it used to be some of the ones that does what this one does. It has the automatic bed leveling. It will detect the spaghetti run out. It has filament run out. It will stop the printer if the filament runs out. Cheap ones have that. But if you're looking to get into it, you're not sure, for about $500, you can get a really good printer, whether it be an enclosed type or bed slinger, open style. You can pretty much get whatever, and it'll do whatever you want it to do. And it's got all the bells and whistles. This one's got a camera in it. It's got a LiDAR detector, so check the thing. It's got quite a bit of stuff in it that is nice to have, and it makes it more convenient, but it's not necessary to print with it. So, that's about it. Any questions?
I just want to mention that I think the Bamboo also has, if you have a power failure, it'll stop the print, power comes back on and things.
Yeah, so that's in the software. Yeah, that's Merlin software, or Merlin software. Bamboo Labs has it, Prusa has it. So as long as the power doesn't go off for too long, and the print really cools down, because then you have to do it. But if the power goes out and it comes back on, say 15, 20 minutes later, the printer will start back up and say, hey, you want to continue the print? You go in there, you look at it and say, and it'll pick up where it left off.
Yeah, I was curious, you had mentioned that you can't print something that's floating in the air. How would it print a ball inside a wall?
Again, it's going to have supports. Now, if you're referring to that little model that has a ball, I think they make a model of a pentagon-shaped cube dish that has a ball inside. Right?
Yeah, if you want that floating rim on it.
For small overhangs and small stretches, the printer can do it. It can just, maybe that much, and it can run a straight line, fairly straight. But it's not really advisable. The problem with that printing and stuff is that it has to kind of push the next layer into that first layer to help with strength. So the other thing you can do is print with supports. A lot of times you'll have something that's hung up in midair, even though it's got a base on it, but the overhang is so great that the plastic won't adhere properly. So you print something that comes up underneath it and acts as a base, and you print on top of that. That's how they do that.
I'll make another mention that if you spend the low end just to tinker with it, so you get an idea of what you're doing. And you're really getting hooked on the hobby if you want to do some Bamboo or something on that size of a printer is much more reliable. Because all the problems are pretty well been solved. I have a Prusa that built as a kit, and they added stuff on top of it for another kit, and a multi-color type thing. And each time you do that, you learn something, and then the thing I learned is, I don't have enough space for all the fruits and stuff.
Yeah.
And, you know, you wanna have an enclosure, because if you have, whether it's summer or whether it's winter, you've got air moving around. And the temperature changes, messes up a printed part really bad.
Right, yeah, PLA is not as sensitive to that,
Yeah.
unless it's a
Maybe
really,
yes.
unless it's a really cold breeze, like you're printing out in the garage and you got the garage door open and this breeze just comes right in. But no, an enclosure is the way to go, because it opens up a lot more doors, and you do, I think, get a little bit better quality print from the enclosed. Anyone else? Yeah.
Great presentation. One thing I would add for this group that she didn't mention is there's a bunch of folks out there that do whole open source projects, and I've seen a couple of ham shacks already, whether somebody I know or on video. And one thing you guys all need is a little bit of organization. There's full projects out there that will print your organization called. If you look up Gridfinity and Multiboard, you can put them in toolboxes, all your little dongles and adapters, the 450 adapters you have to play puzzle with later, all go in one toolbox, labeled, lots of organization.
Right, yeah. For those of you who don't know, Gridfinity is a system, I forget who invented it, but instead of charging for it, it's free. He gave it out to the community. And what Gridfinity is, you have a drawer. We all have that drawer at home, just everything everywhere, right? And then you say, well, I'm gonna fix that because I'm gonna put stuff in little containers. We put containers here and there. But everything gets everywhere anyways. Gridfinity is a track system. So it makes a bunch of squares. They're not very thin, just an eighth of an inch. And you lay it down in the drawer, and then you print containers. You can print a 1x square container, print a 2x, you can print 2x2, 3x3, 4x4, whatever it is, and that snaps in. So it snaps into the grid that you have in your drawer. And if your grid is as wide as your drawer, well, stuff's not gonna move around. But that's, yeah, grid fitted.
Just had a question. Have you ever downloaded software or maybe an object, you're looking at it, and then the thing starts printing and there's a snafu and it's not what you downloaded? You get to see an image of it if somebody has an object and you just download it and open it up.
No, yeah, when you go to these sites, so there's,
You see some interesting things coming out of there.
well, the biggest one is like Thingiverse. There's Thingiverse, there's Maker World, those are,
Printables.
what's that? Printables. Printables. You can go on there and you'll see an image of what you're gonna print.
Well, so when you slice it.
Yeah,
you'll
it'll
see
show
before
you.
it goes.
Right, you see it before it goes.
And just if people are interested, there's a group on Facebook I joined a while back. That's all about different things people 3D printed for their ham shack. As like 3D printing hams or ham 3D stuff like that. But it's all this type of stuff, and even down to like faceplates with Go kits and everything. So it's really interesting.
Yeah, you can certainly do that. This was also done, this was done for my grandson, David. It's a little keychain with his name tag on it. Well, you can put anything you want on there. You can make it for tags to go on your antenna so you know what it is or what you know, hey, this wire is from this 4 meters.
Moorpark College has a great makerspace program that at no cost, there's a couple of prerequisite courses that you need to take. They're all done at home, and once you've completed those courses, you get access to all of their 3D printers. They have a resin printer, they have laser etching, all sorts of great makerspace products. So you just pay for the materials, and it's all, the courses are free actually.
Yeah,
It's a great
I
program.
think there's a makerspace out here too, in Westlake, that's trying to get going there.
Yes, COU LA campus, Westside campus has it. With the Nera.
Set fire to it.
And that's a good thing too, go in there and ask questions.
That's right.
Anything else?
Yeah, with that.
All right, thank you very much.